All right, here's the video for Notes 2-2 special right triangles. So first we're going to start out with what's called 30, 60, 90 triangles. So first of all, let's talk about equilateral triangles. So in an equilateral triangle, we know that all sides are equal, as well as all angles are equal. So now what we're going to do is we're going to find the height of the triangle. Well, if I draw in the height of the triangle, something like this, right? And here's what I know. So to find the height, I basically kind of split this equilateral triangle into two triangles. And using this triangle on the right-hand side, well, I split this in half, which means this side is 1, the hypotenuse is 2, and this is what I'm solving for. Well, I can just use Pythagorean theorem to solve for the third side, right? Here's my right angle. So I'm going to do 1 squared plus x squared is equal to 2 squared. All right, simplifying here, 1 squared is 1, and 2 squared is 4. So now I'm going to subtract 1 from both sides. So I have x squared is equal to 3. And then last step with Pythagorean theorem, we need to take the square root of both sides. So that means x is equal to the square root of 3. So what we've done when we split this triangle in half, we actually created two 30, 60, 90 triangles. The reason why this is a 30, 60, 90 triangle is because, well, we know that every angle is 60 degrees. Okay, and this angle was split in half. So there's a 30 degrees. So here's the 30, here's the 60, and here's the 90. This is a 30, 60, 90 degree triangle. A 30, 60, 90 triangle has this short side, which is going to be the side length of 1, this long leg, which is going to be the side length of the square root of 3, and then we have the hypotenuse, which is going to be equal to 2. All right, so now let's talk about 30, 60, 90s because this is a special type of triangle that we're going to use to be able to solve for missing side lengths of other 30, 60, 90 triangles. A 30, 60, 90 triangle is half of an equilateral triangle. Its short leg, so remember these are the legs right here. Its short leg, which is this one, is equal to 1. And this is across from the 30-degree angle. The long leg, which is across from the 60-degree angle, so this is the long leg, this is going to be equal to the square root of 3. And then we have the hypotenuse is equal to 2. And we know that the hypotenuse is always across from the right angle. Okay, so this is a 30, 60, 90 triangle. We need to memorize this or put it on our note card so we can use this to solve for missing sides of other 30, 60, 90 triangles. Okay, what's special about a 30, 60, 90 triangle is it's similar to all other 30, 60, 90 degree triangles by angle, right? If we have another triangle that has an angle, a 90 degree angle and either a 30 or a 60, we know they're similar by angle. So then we can use what we know about similarity to solve for missing sides. All right, so now let's take a look at an example. So in order to do these problems, we are going to need to use that 30, 60, 90 triangle. So what I like to do is kind of just sketch a picture. Remember, the short side is equal to 1. The long side, or the long leg, is equal to the square root of 3. And the hypotenuse is equal to 2. So what we're going to do is we know that these two triangles are similar by angle. And now we're just going to match up short, long, and the hypotenuse to solve for the missing side. All right, so first thing, let's label these sides. So this is the short side, this is the long side, and this is the hypotenuse. And now we're just going to match up sides. So I'm going to call NEX, and I'm going to call EWY, and we need to solve for both. Okay, so to solve for X is going to match up with the short side here. So X over 1 is equal to, and then we're going to use the information we have here, the hypotenuse, which is the square root of 3, over the hypotenuse here, which is 2. So these are my short sides, and these are my hypotenuses. And now we're going to see if we need to cross multiply. Well, I have x over 1. I already have x by itself, which means this is the length of the hypotenuse. So NE is going to be equal to the square root of 3 over 2. Now let's solve for y. So solving for y, that's the long side. So I'm going to match that up with the long side here, y over the square root of 3. And then again, I'm going to use the same ratio, the hypotenuse, square root of 3 over 2. So I matched up my long legs, I matched up my hypotenuse. In this case, we are going to have to cross multiply since y is not by itself. Here, x divided by 1 is just x. We didn't have to cross multiply. So y times 2 is 2y. And then here I have square root of 3 times square root of 3. Remember, that's square root of 9, and the square root of 9 is just 3. Or you can think that the square roots just cancel out. So we're left with just 3. And then to finish this problem, we need to divide both sides by 2. So y is equal to 3 over 2, or 1.5. So our other missing side, EW, is equal to, I'm going to leave it as a fraction, 3 over 2. So again, just using similarity to match up your sides. All right, let's look at this one. So we're solving for FU, and we're solving for FT. Okay, I just like to call them X and Y just because, I don't know. All right, so let's solve for X first. So again, X is, we know the short side. So I'm going to match that up with short here. So X over 1 is equal to 12. That's the long leg, and that's going to match up with the square root of 3. All right, let's see if we need to cross multiply of x over 1. X is already by itself, so I just have 12 over the square root of 3. However, remember, we're not allowed to have a radical in the denominator, so we are going to have to rationalize our denominator. So multiply by our big 1. So we have 12 root 3 over 3. And then if we can simplify here, we should. So 12 divided by 3 is 4. So we have 4 times the square root of 3. So x, which is FU, is 4 times the square root of 3. All right, now let's solve for FT, which is y, and that's the hypotenuse. So I'm going to match that up with the hypotenuse here. So y over 2. So hypotenuse, and then again, I'm going to use the same ratio here, 12 over the square root of 3, which is the long leg. All right, this one we are going to have to cross multiply. So we have y times the square root of 3 is equal to 12 times 2, which is 24. And then we're going to divide both sides by the square root of 3. All right, in this case, just like here, we're going to have to rationalize our denominator. So we're left with 24 root 3, and square root of 3 times square root of 3 is just 3. And then lastly, if we can simplify, we should. 24 divided by 3 is 8. So it's just going to be 8 times the square root of 3. So just using similarity to solve for missing sides, and then we have to simplify, use what we know about simplifying radicals. So now let's take a look at 45, 45, 90. So 45, 45, 90, let's first talk about squares. So squares, we know all sides are equal, and we have 4 right angles. So next thing we're going to do, in order to form a 45, 45, 90 triangle, we're actually going to split the square in half. So this creates a 45, 45, 90 triangle. So there's a 45, there's a 45. We're going to find the length of the diagonal. Well, if we know that all sides are equal, we know that this side has to be 1, and then we can just use Pythagorean theorem like we did. So 1 squared is 1. So we have 2 is equal to x squared, and then lastly, we're going to take the square root of both sides. So x is equal to the square root of 2. So now what we've done is we've created our 45, 45, 90 triangle, and we're going to do basically what we did with 30, 60, 90 triangles, and we're going to use this 45, 45, 90 triangle to solve for missing sides of other 45, 45, 90 triangles. So 45, 45, 90 triangle is half of a square. We know that their legs have to be congruent because remember, it's a square, so these legs always have to be congruent, and they're always going to be equal to 1 in our basic 45, 45, 90, and this is what we use to compare 45, 45, 90 triangles to. And then our hypotenuse is always going to be the square root of 2 for our basic 45, 45, 90 triangle. Just like with 30, 60, 90 triangles, 45, 45, 90 triangles are similar to all other 45, 45, 90 triangles through angle, angle, which means that we're going to be able to use similarity to solve for missing sides of a 45, 45, 90 triangle. Okay, so let's take a look at a couple examples. So like with the 30, 60, 90, we're going to always draw kind of a basic 45, 45, 90 or have it readily available, 1, 1, root 2. And we're going to use this to compare it to other sides. So we're going to call these the legs, and this is the hypotenuse. Leg, leg, hypotenuse. And we're going to solve for the missing side length. So in this one, we're solving for DE, and we're solving for DF. Well, what's nice about 45, 45, 90 triangles is if you have one leg, you automatically have the other leg because remember the legs are congruent. So this is going to be 3 times the square root of 5. And that's because we have congruent legs. So there's no work to be shown for that one. To solve for DF, we're going to have to use similarity. Okay, so solving for DF, I'll call that X. So I'm going to match up my sides. So X goes with my hypotenuse here. So this is the hypotenuse. So X over the square root of 2 is equal to, and then we're going to use information here, 3 root 5 over 1. And then we're going to cross multiply. So X times 1 is X. And then 3 root 5 times 2. So remember, the numbers on the outside stay on the outside, and then we can multiply the numbers on the inside. So 5 times 2 is 10. This can't be simplified, so this is actually going to be the length of DF. So 3 times the square root of 10. All right, taking a look at the second example. So again, we're solving for JK. And well, we know that that's going to equal KL. So really all we're solving for is one side. Okay, so X over 1, those are the legs. And then we're given the hypotenuse, 22 over the square root of 2. So this one we don't have to cross multiply because we have X over 1, which is just X. What we do need to do is rationalize the denominator here. So 22 times the square root of 2 is going to be 22 times the square root of 2. The denominator just becomes a regular 2. And then if you can simplify here, 22 divided by 2 is 11. So 11 times the square root of 2. So that means JK is equal to KL because the legs are congruent. It's just going to be 11 times the square root of 2. All right, so now let's take a look at a couple of these homework examples. So starting with the first one. So this is a 45, 45, 90 triangle. So what I'm going to do off to the side here is draw a 45, 45, 90. We know that's 1, 1, root 2, leg, leg, hypotenuse. And I'm going to label on this triangle, we have our leg, leg, and hypotenuse. Well, in this case, we know that V and U are equal because they're the legs. And now we're going to solve for either V or U using the side that we're given. So I'm going to say V over 1, so matching up the legs, V over 1 equals 2 root 3 over the square root of 2. So these are my legs, these are my hypotenuse. We don't need to cross multiply because we have V by itself, but we do need to rationalize. So multiply by the square root of 2 over the square root of 2. Numbers on the outside stay on the outside, numbers on the inside you can multiply. The denominator just becomes a regular 2. And then lastly, outside can simplify. Those just cancel out. We're just left with the square root of 6. So V and U are both just going to be the square root of 6. All right, now let's take a look at number 6. So this is a 30, 60, 90 triangle. So I'm going to go ahead and draw my 30, 60, 90 triangle. So my 30, 60, 90, I have my short leg, I have my long leg, and I have my hypotenuse. The short leg is 1, the long leg is the square root of 3, and the hypotenuse is 2. Okay, so I'm going to label short, long, and hypotenuse. And I'm going to solve for y first. Okay, so y is the short side. So I'm going to match that up with the short side. So y over 1. And the information that they give me is the hypotenuse. So 4 root 3 over the hypotenuse, which is 2. All right, this one I do not need to cross multiply since I have y by itself. So now we just need to see if we can simplify this. Well, I can actually simplify 4 divided by 2, which is just 2. So that's just going to be 2 times the square root of 3. So y is equal to 2 square root of 3. Okay, now let's solve for x. So that's going to be my long leg. So x over long square root of 3 equals, and again, we're just going to use the same ratio here, 4 root 3 over 2. All right, this one we do need to cross multiply since I don't have x by itself. So x times 2 is 2x. And then 4 times the square root of 3 times square root of 3. So 4 stays on the outside, and then I can multiply these. Well, in this case, the radicals cancel out. This just becomes 4 times 3, which is going to be 12. From here, we're going to divide by 2. So we're going to get x is equal to 6. All right, I'm going to jump actually over to number 10, since this is also a 30, 60, 90 triangle. I'm going to label, this is the short side, this is the long side, this is the hypotenuse. And we're just going to match up again using our basic 45, 40, or basic 30, 60, 90 triangle. So I'm going to solve for y. So y over 1, short over short, is equal to long over long, 9 over the square root of 3. All right, no need to cross multiply since y over 1 is just y, but we do need to rationalize. So my big one is square root of 3 over square root of 3. So then I have 9 root 3, and square root of 3 times square root of 3. The radicals cancel out. We end up with 3. And then we can simplify here. 9 divided by 3 is 3. So it's going to be 3 times the square root of 3. Now let's solve for our hypotenuse, which is x. So x over 2, hypotenuse over hypotenuse equals, and again, we're just going to use the same ratio, 9 over the square root of 3. That's the ratio of the long sides. This one we do need to cross multiply since x is not by itself, so we get x square root of 3 is equal to 9 times 2, which is 18, and then divide both sides by the square root of 3. Well, now we have x by itself, but we do need to rationalize. So square root of 3 over square root of 3. Top becomes 18 root 3. The denominator just becomes a regular 3. And then last one, this is as complicated as it gets. 18 divided by 3 is 6. So we just have 6 times the square root of 3. So final answer here, x is equal to 6 times the square root of 3. All right, now with our last one, this is a 45, 45, 90. So basic 45, 45, 90, 1, 1, root 2, leg, leg, hypotenuse. And I'm going to label here, leg, leg, hypotenuse. Well, we know a and b are equal, so we can just solve for one of them. So a over 1 equals 10 over the square root of 2. So leg over leg equals hypotenuse over hypotenuse. Okay, no need to cross multiply since a is already by itself, but we do need to rationalize. So my big one is square root of 2 over square root of 2. So on top we get 10 root 2. Denominator we just get a 2. And then 10 divided by 2, we can simplify that to 5. So 5 square root of 2. So a and b, since the legs are congruent, are both going to be 5 times the square root of 2.